So binary numbers, so numbering system here. Okay, so we are going to do a very quick review based on what we already know, right, in our everyday language, and then we are going to try to map it to different bases. Okay, and one of the most important one is the binary numbers. Okay, so binary. Okay, let me grab my pen over here. So we all know binary. So basically, it's either, okay, the digits we use is either 0 or 1. Okay, binary arithmetic. It's just zeros and ones. Okay. So before we come there, before we come back to that, let's do some quick refresher. This is our everyday language. Okay, this is our everyday language. Okay, so base 10. This is the decimal math we talked about. This is how we speak in our everyday language. When we go to the market, we basically speak in base 10, which is the decimal math. Okay. So when you come to base 10, which is our normal decimal math, okay, we have 10 unique digits, right? And that's why it's base 10, right? Because it contains 10 unique digits, our decimal math, right? From 0 to 9, you will get 10 unique digits. Okay, so any base which will have, let's say, 3 unique digits will be a base 3. Base 2 has 2 unique digits, right? 0 and 1. That's why it's binary. That's why it's base 2, right? Okay, so that's one. Okay, the second thing, when we are dealing, let's erase this one here. When we are dealing with base 10 and we say 123, okay, indirectly, this is what we mean. So don't forget base 10, right? So we have 10 unique digits, so we are dealing with base 10. When we say 123, right, if you expand it, okay, then basically this is 1 in the hundreds column, so 100, right? We have 2 in the tens column, so 20, and then we have 3 in the unit single digits column, which is basically 3. Okay, so if you look at the expansion, we have 10 raised to the power 0, base 10, right? Decimal. 10 raised to the power 1, the next digit, right? Then the third one, 10 raised to the power 2, and if there's more digits, it's going to follow in that fashion. Okay, it's going to follow. So based on these, okay, based on these facts, we can apply the same to any base when we want to find the decimal equivalent, right? When we want to find the decimal equivalent of that base, right? We just want to make sure that we use the base, okay? So the base raised to the power 0 for the first digit, base raised to the power 1 for the second digit, and so on and so forth, okay? So that's the second one, okay, which we normally do sometimes without even thinking about it, okay, which we normally do without thinking about it. The third one, which is very important, okay, because sometimes you get indirect questions related to that, okay. So base 10 decimal, right? If we have a 4-digit number in base 10, so somebody say, okay, I want you to write there, you know, whole number, no fractions, right? The highest number in base 10 with 4 digits. For sure, you know, it's going to be that, right? It's going to be that. 4 digits, base 10, no fraction, right? So we know it's going to be 9,999, right? So this is the highest number you can represent in base 10 in our normal language, right? If we limit you to 4 digits, okay? This number, okay, the highest number, okay, which you can represent with 4 digits, can be represented as that. Okay, so our base 10 raised, which is 10 raised to the power the number of digits you are allowed, okay, to represent the number minus 1. This will always give you the largest number you can represent for any base. Okay, so when you are dealing with base 3 and you have 3 digits, right, and this is going to give you the decimal equivalent of that number. Okay, always the decimal equivalent. So when you are dealing with base 3 and you have 5 digits, the highest number you can represent in base 3 with 5 digits, right, is going to be 3 raised to the power 5 minus 1. This will be the decimal equivalent of the number you can represent in base 3 with 5 digits, right? So very similar to that. So we do this every time, but when we take a second look, we see that we can apply it to other bases, right? We can apply it to other bases.